Welcome. We are going to discuss Rolle's theorem in a different style, in a different explanation. What is Rolle's theorem? First I am saying it, that is, if a function fx equals to 0 has two consecutive real roots, then between these consecutive real roots there will be at least one real root of f dash x equals to 0, or there will be an odd number of real roots. Now before entering I will say two things. What is meant by root? Where fx equals to 0 is crossing the x-axis, that value of x is known as a root of the equation. And what is the root of f dash x equals to 0? Where the tangent to f dash x, if it is parallel to x-axis, at that point it is known as f dash x equals to 0. Now let us see one graph. Suppose a function is there. Like this. In this case, see, these are called, suppose at these points were A and B. At these 2 points, there are 2 real roots are there. Because at this point y equals to 0, these are 2 consecutive real roots. In between these two, see here, this is the graph. If we are drawing tangent, you will get only one point where tangent is becoming parallel to x-axis. That point is known as turning point. There should be at least one turning point. Okay. Here, if you are seeing in this graph, suppose this is 2 points, P and Q. So x equals to P and x equals to Q are 2 consecutive roots of fx equals to 0. In this case, in between these views, the graph is moving like this. See, graph these points are called turning points. Okay, so there cannot be, after each turning point, the graph is changing direction. So after two change, it is coming back to the original direction. So there cannot be any root here. So that's why there cannot be 2 roots between 2 consecutive real roots of fx equals to 0. There may be 1 root, there may be 3 roots where f dash x equals to 0. In this way, there can here if you are saying, suppose this point is R, this point is S, you will find there are 2 consecutive real roots, 1, 2, 3, 4, 5. If you are trying to get after 2, that there will be 2 roots, how this line can cross x-axis if it is not coming downwards? That means if it is not turning. So at least one more turning point is there. So after 2, there cannot be, there will not get another root. For getting another root, it has to again take turn. So that's why there will be only odd number of real roots of f dash x equals to 0. This one I have explained only for understanding. We have already proved in another class that algebraically we have shown you, but graphically using calculus we are explaining that why it is like that.